Hello everyone, this is Tony Anderson. In this video, I will highlight a few of the main ideas from Chapter 2. Chapter 2 is about systems. Systems theory is a foundational concept for the study of group communication. This idea is presented early in your textbook because we need to understand how systems operate before we can move on to consider various aspects of group communication. The systems movement spans multiple disciplines. One of its founders was a theoretical biologist, for example. Systems concepts can be applied to a large number of fields. We use the idea of a system as a metaphor for group communication. So how can systems be used to describe or explain what happens inside a group? If groups are systems, the important elements within them are people, their behavior, and their points of view. Here's another way we can apply the systems metaphor to the idea of a group. Groups are like complex organisms. So if a group is an organism, what is outside of it? The answer is its environment. All systems must interact with their environment to survive. So let's talk about system components. A system is an assemblage of parts, and these parts have interdependence, or what happens inside the system. Interdependence is the need of components to rely on other components in order to function. The parts of a system also have permeability. Permeability is the ability of components in a system to allow information and materials to flow in and out. From a group communication perspective, permeability refers to how open or closed a group is to outside information and influences. Next, let's discuss the processes of systems. Systems are characterized by input, throughput, and output processes. Exchange is one process. There is the input of materials and information. Then there is the transformation or throughput of those materials and information. And lastly, these are turned into output that goes outside the system. A group example might be the way in which a group of people might produce a product or information such as a report. Another system process is feedback. Feedback is information that helps to facilitate the interdependent functioning of system components. Feedback can be positive or negative. Positive feedback promotes growth. It is information that serves to change system functioning through development. Negative feedback is not necessarily a bad thing. Consider this as corrective feedback. It is any information that serves to keep a group functioning and on a steady course. Next, let's discuss the properties of systems. Holism is one property. Holism is the idea that a system is more than just the sum of its parts. Consider this bicycle. Is a bicycle simply the sum of its parts? We can't reduce a bicycle to its parts and still retain the meaning or function of that bicycle as a whole. Another system property is equifinality. This is the idea that a system can reach the same final state from differing initial conditions and by a variety of paths. This implies there is no one right way to accomplish something. Another system property is entropy. Entropy is a lack of order or predictability. It is a gradual decline into disorder. Systems must battle against entropy. Negative entropy is the ability of a system to sustain itself and grow. So do you think there's a perfect balance between stability and change for a system? The answer is no, but there is a range in which systems can manage change effectively to promote growth without destroying the system with too much instability. This range is called dynamic equilibrium. Here is an example. Have you ever played Jenga? The process of carefully selecting and pulling out blocks, then putting them back on the top of the stack without knocking the stack over, illustrates the delicate management of stability versus change or dynamic equilibrium. To sustain dynamic equilibrium, a system must regulate these three things: the degree of change, the rate of change, and the desirability of change. I will discuss each of these using Jenga as an illustration. In the game of Jenga, how many blocks are removed and restacked onto the top of the stack affects the stability of the stack. This is the degree of change, or how much or how big the change is. How fast or how slowly the blocks are removed in Jenga also affects the stability of the stack. That is the rate of change, or how rapidly change is happening. Choosing some blocks as opposed to others in Jenga is a critical decision, also affecting the stability of the stack. This illustrates the desirability or value of the change, or making the best decision about change to minimize risk of destabilizing the system. So how well can you maintain dynamic equilibrium? I have provided a virtual version of Jenga in this week's course module. It's there just for fun. Try it out to see how well you do. You might have heard of the term synergy. This is the idea that groups produce a better quality result when people work together than when they work solo. Our experiment last week with drawing a human was intended to test this idea of synergy. In our experiment, remember that we started as a whole class. You each drew a body part on your own, and you were not allowed to communicate or collaborate in any way. Then in part 2, you were split into groups, and it was up to each group to decide as to who drew which body parts, what style those body parts might take, and so forth. As of the making of this video, your class has not completed this activity yet. We still have to do either the second part or the wrap-up. So I don't want to give too much away about how we're going to finish out this activity in our upcoming virtual session this week. But what you see here are humans that were drawn by some of my prior face-to-face classes. So let's take a closer look at these drawings. Can you guess which of these were completed while group members were able to communicate, and which were created by individual students who weren't allowed to communicate? And can you guess which were completed more quickly? Synergy is the idea that groups produce a better result when people work together than we work solo. So your opinion on which of these is better is subjective, because is our definition of better to do with technical accuracy, consistency, or creativity? So we would have to define our term of better to really compare. What does that mean? I look forward to continuing this discussion of synergy when we look at your human drawings this week during our virtual session. So that is it for now. If you have general questions about this week's assignments or readings or this class, please let me know through the Q&A discussion forum. And if your questions of a more private nature, please email me. Thank you for taking the time to watch, and I wish you all a good week.